length in geometry was your central angle over 360 times 2 pi r. Do you remember that? Vaguely? Okay. Well, in advanced algebra, we no longer are dealing with arc length in terms of degrees. We're going to deal with it in terms of radians. So we're going to deal with arc length solely in terms of radians. So what I want to look at here is, how do you convert degrees into radians? Do you remember? So degrees to radians, you went angle over 180, and then what? Slap a pi next to it, and that gave you what we call theta. And theta was the angle measured in radians, remember? Yes. So let's look at this generic formula here for arc length, which we've seen back in geometry, and let's see by chance we can make it look like that. How many times does 2 go into 360? A lot of times, yes. So that becomes pi over 180 times the angle times r, right? Isn't that the same thing as saying theta times r? So there's your formula. Area of a sector, or excuse me, arc length. Arc length now in advanced algebra. Arc length is now equal to theta times the radius, or r times radius times theta, where theta is the angle over 180 times pi. It's just your central angle converted into radians. This is all done in radians, guys. Now, once again, you're going to see stuff where you guys are going to go, I don't know how to work with fractions. If you have forgotten how to use fractions and how to simplify them, what do you guys all have access to? A calculator. For example, let's say we want to find the arc length where your angle is, I don't know, 40 degrees and the radius is 6. Just for a quick example. If I'm giving you the angle in degrees, means we have to convert it to radians. So that becomes angle over 180, slap a pi next to it, times 6. You agree? Now, if you have forgotten completely how to simplify fractions, which you have, now I'm getting the big glazed look of people going, what happened? Remember, in your calculator, you could do this. As long as you put this in first and this in second. Math, enter, enter, and it'll simplify it for you. Okay? Unfortunately, you guys were given a very, very, very large disservice about how you go about simplifying fractions. It's one of those things. Okay? So that's your arc length for that. I might just rip it over. There. Next time you do it, go, cough when you do it. It'll be a little bit less obvious. Okay? So don't freak out when you have all these fractions. This means all of your arc length problems that we're going to have, and then when we start dealing with the area of the sector, it's all going to be in terms of radians. And there's no degrees in these things. Okay? We all right on that? All right. Now, the other formula that we're going to look at today, not only just with arc length, is we're also going to talk about the area of the sector. Remember, the sector is the wedge. It's the wedge of the circle. It's that piece of pie. It's pie cut pizza. I see what you did there. Okay. So when you're dealing with the area of a circle, or excuse me, the area of a sector, you use the same idea where the area of the sector, let me move this over here, is going to be 1/2 the radius squared times theta. And once again, what is theta? Theta is going to be the radian measure. It's the radian measure of your central angle. Okay? Theta is the radian measure of the central angle. So in that last example that I just gave you, I had, well, let's take this a separate sheet. We had the angle was 40 degrees. And what was my radius again? Was it 6? Okay. So if I want to use that same exact values, because you're going to see a lot of problems that say find the arc length and then find the area of the sector. So you take 1/2 of 6 squared times the, the 40 over 180, slap a pi next to it. Once again, simplify your fractions as you're going. What's 6 squared? What's half of 36? Okay. All right. You ready? Once again, if you can't do that, bless you. If you can't go 36, you can't simplify that quickly, use a calculator, slap a pi next to it. And you're done. Central angle, I remember going central angle over 180 times 5 and converting it to radians. Theta is always your degree or your central angle in terms of radians. We're not doing any of this in degree measure. Everything's going to be radians. Sometimes they'll give you the problem already in radians. Sometimes they're going to give you in degrees. I figure if I show you the ones with degrees, it's the more difficult examples. Because the radians, you're done. You don't have to do any extra work. Okay? What did I do? No, because this became 18. 36 over 2 is 18. And that became 18 over 18, which is 145. Same. All right, try this one then. Find the arc length and the area of the sector that has a radius of 9 and a central angle of 60 degrees. So your central angle is 60 degrees, and your radius is 9, and I would like you to find both the arc length, and I want you to find the area of the sector. Take a minute and find both of those. We have 60 over 180 times 9 times pi. We got 3 pi. You did something wrong. And then the sector, we have 1/2 of 9 squared times my arc length, or excuse me, times my central angle. So it's 60 over 180 times the pi. Once again, that's going to be 1/3. So it's 81 over 2 times pi over 3. 3 goes to 81 27 times. You get 27 pi all over 2. Once again, guys, if you're not getting those answers right, just make sure you use your calculator correctly. I will tell you one thing, that you got to get some fractions going, because we use fractions a lot in chapter 14. We're graphing sines, cosines, and tangents. Okay? So we're 2 out of 3, we're 2/3 of the way done. 2 out of 3 of the way done? No, 2/3 of the way done of today. Area of a triangle. This is the other formula I want to discuss with you guys. Remember, we all know that the area of a triangle can be found by 1/2 base times height. Well, sometimes we're not able to figure that out simply. So what we're able to do is that if you have a side angle side situation with any triangle that has a side angle side setup, where you're given two sides and the included angle, you can find the area of that triangle by taking 1/2 the side times the side, and whatever the included angle is sine. Okay? So if you're looking at what you've got triangle A, A, B, and C. I'm trying to just use my letters correctly here. If I'm given side A and side B, and I know that side or angle C is the included angle, I'm given that information. All I do is I take 1/2, multiply the two sides together, take the sine of the given angle. There's my area. Should you be in degrees or radians, you think? I should be in degrees. I'm dealing with triangles here. Figure you can cover both, you'll be all right. You want to be in degrees. So once again, this is a fairly simple setup. All you have to be able to know is that you've got two sides and the included angle. So basically, for any of the triangles that we've worked with right now, when you're solving your triangles out, whether you're using law of sines, law of cosines, any of those, I could actually tack on one question and say, what's the area? Okay? And you'll be able to find that. It'll work. So, let me show you an example of how this looks. Remember, these three formulas are the exact same thing. Take 1/2, the product of the two sides, and the sine of the included angle. That's how you find the area.
That's for side angle side.
Only for side angle side, because you have to have the two sides and the included angle. Now, what if it was one of the triangles that you had all three sides? You know how you use law of cosines to figure out one of them?
You can use it then.
Then you can use it then, yeah. But you have to
You need two sides.
you have to have two sides and the angle between them in order to do this. Those are the ones you use. Okay. So for this case, let's look at this one. The two sides I have are 3 and 5, and the included angle is 55. I don't have to solve the triangle or anything like that. I just want to find the area of that triangle. So all I have to do is I take 1/2, well, take the two sides, and the sine of 55. And that's my area. So when I'm using my calculator, am I going to use 1/2 or am I going to use 0.5 for ease? 0.5. There's your area. What's that? No, I could make it tougher. Usually what will happen on something like this, I'll tack this onto like a law cosine problem or something. I'll just ask you, what's the area? Okay. Because it is a fairly simple setup. Notice how you have side angle side here. You've got two sides and the included angle, and that's all you got to be able to do. Okay? One more. Let's do number 14. What'd you get?
99.39.
99.39? Okay. Now, the other part of this, these problems aren't going to take you very long. Okay? They're not going to take you very long at all. What I'd like you to do also is to start looking at the chapter review. I think it starts on 8:22. And we've done all sections. We did 13.1 through 13.6. It's about 30, 31 other problems. But it would probably be a really, 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 really good idea to start looking at those over the weekend. So that way on Monday, after we go over these problems, we have more to look at, more to talk about to prepare for the exam on Tuesday. There will still be calculator, non-calculator on the test, okay? So once again, the way that the questions are worded and everything are going to be identical to what you see in the book. So take some time over the weekend and go through those as well.